In this tutorial, I'm going to show you what makes up a hash table. You could use a built-in API in Java, but I'm going to show you kind of how you can do it from scratch so you can really understand what's going on in a hash table. And this works similarly in other languages, but we're going to look at this in Java. All right, so hash tables would be great for large data sets. In my little example here of some stock ticker symbols and stock prices, I'm using just a very small data set that's about 10 values. But to really get the power of it, you would have a large data set. So, all right, so here's what we got. These are 10 stock ticker symbols and 10 prices. These aren't the actual prices, just so you know. But these will be parallel associated with each other here. And so you can imagine this coming in from maybe like NASDAQ's API or something like that. And you would save that to a hash node. Hash node would be a class that I'm going to show you in a minute that just has a key, which is in this instance is our Amazon stock ticker symbol, and a value, which is the stock price. And your hash table class, the main feature of that is it has an array of linked lists, right? So here's your array and it holds linked list, and each of the spots in the linked list holds the hash node that has your key value information in it, right? And so one of the key functions though of that in that hash table are what's called the hash codes. We produce hash codes to figure out where we're going to store which spot in this array we're going to store the hash node. Okay, and how we do that, this is a quick overview of how we do it. We calculate our hash codes by summing up the ASCII values of our key and then mod it by the size of the array. So our array in this instance is 10. So if we're looking at Amazon as our example, these are the ASCII values for each of those characters that make up the stock ticker symbol. Sum them up, that's 310. You mod it by the size, which is in this instance 10, and so we get 0. So this is going to go in spot 0. So there was already something in here, let's say, and so it's going to be in the second spot of the linked list that's in that array, and that's how it's determined. And so you want to try to avoid as many collisions as possible, and I'll show you in a second a way that you can try to minimize the amount of collisions you have, so that because ideally you'd want each of these linked lists to just have one element in it, right? So let's take a look. So this is an ASCII table, just so you understand where I was getting those numbers from. The A is 65, the M is 77, and so on. And just so you see, the one method you can use, there's been some studies, and they say like the optimal way to do it is to multiply the size of your array by 1.7, so like increasing it by 70% is ideal, so that you have the least amount of like wasted spaces in your array, but you get the least amount of collisions. And you see in this instance we actually go from having 9 different collisions to just having 4. 2 sets of 2 in this instance. And then, if this was a large database, you could extrapolate that out and hopefully save you really minimize the amount of collisions. Here's what our hash node class looks like. Super simple. K and V just represent generics. You can I'll share this code with you, but by having generics there, then your key and your value could really be of any type, so it just makes your code more flexible. And all that's in here is a constructor that initializes the values, okay? And then let's just take a closer look at the hash table code. So if we're looking at our hash table, we're going to, that's our runner. Here's our hash table. 2 class variables, and one's the size of our array, and then the linked list made of hash nodes, right? I showed you our hash node, but that's what's holding that linked list. And like I said, so ideally you'd want to multiply it by 1.7, so that's your new size. You want to go ahead and initialize each spot in your array with a linked list. Otherwise, when you go to add, you're going to get an error. So that's why you do that. And then here's our simple add function that we call our hash code function and send it our key, which in our example was the AMZN. And this is just for testing purposes to print out. And then we just simply will add our hash node to our linked list in that spot in our array. Right, and just so you get a quick look at what the hash code function looks like, we make sure that, so we're taking in it as a generic type, but we're going to convert it to a string. 99% of the time, your key is a string. And then we go through and look at each character in that string, find its ASCII value, that's what's happening right here, and we add it to this hash value that I have, and then we return the hash value, mod it by the size. There you go. That's it. This is it. I'm not going to get into, I'll just show you real quick, because one of the advantages of the hash table is the find feature, because in other data structures, you got to search through it. You got to go with n number of times, the whatever, if n represents the size, right? But in a hash table, it should be O of 1. If you have some collisions, maybe it's O of 2 or 3. But you can imagine if there's 10,000 data points in here, to be O of 1 is going to save you some time for sure. And so you do the same thing when you go to find. You get your hash code, and then we will retrieve the linked list that's in the spot that hash code represents. And then we simply look through the linked list to find our key, right? So we're going to do this for loop to go through. And if we find the key, then we just return that value, right? So again, hopefully hopefully this for loop only runs once. But at a minimal, it's going to run maybe 2 or 3 times. So much quicker for extracting our data. And here's what your runner class could look like. We have those data sets that I was talking about, and we are creating a hash table object with size 10. And then we're just going to go through and create a hash node for each spot in these arrays, and then add that node to the hash table. And then we can simply retrieve it by doing ht find, and I just showed you that method. So that's it. That's a kind of a quick tutorial. I mean, obviously your hash table would probably have some other functions like set to change a value, and maybe remove. But that's it, quick and dirty, what a hash table is. Hope this helps. Let me know if you have any questions, and please subscribe.